Hey everyone, so this is going to be the next thing that I want to talk about, which is the center of mass. I think this is really the only other aspect that is going to be different. There might be one other thing that I have to mention, but uh, this is it for now. It's about finding the center of mass. So uh, in AP1, we're going to figure out how to find the center of mass, uh, either for a uniform object or a somewhat unbalanced object. But we won't actually have to calculate what the center of mass is. For the most part, we'll just need to know roughly where it is. So, one thing that we're going to mention in class, I don't recall if I'm going to mention it in the momentum section, but we'll definitely mention it in the rotation section. But if we have an object that has what's called uniform mass, that basically is the AP's way of saying that the center of mass is right in the middle. So if you have a beam of uniform mass, the center of mass is directly in the middle. That's where you put your finger to balance it. Easy enough. Now, if we have two objects that are on either end of the beam, let's say, we can actually find their center of mass just by conceptually thinking about, again, where we would put our finger in order to balance it. So if we had a situation like this, where we have one ball on the left and one ball on the right, the ball on the left being significantly more massive than the ball on the right, then we know where the center of mass would be. It should be a little bit closer to the heavier object. So of these three choices, one would be my answer. If for some reason these two objects were of the same mass, like I don't know, two two different objects of different densities, uh, made in such a way that they have the same mass, their center of mass would be in the middle. And if for some reason this one was more massive, this would be the center of mass. So conceptually, this is as far as we go in AP Physics 1. We just need to know roughly where the center of mass is. And again, it will usually be located closer to the heavier object. Now, um, there is an APC. You're going to actually have to figure out. You're going to actually have to calculate this. There is an equation on the reference table. It's given by this form. So it says xcm equals sum mi divided by sum mi. Now, what does all this mean? We're going to do a quick little practice to kind of show you what it is, but to briefly run through it, this is talking about the position of the center of mass. That's what x is your position, cm is center of mass. This is saying the sum of all the masses times their positions divided by the sum of all the masses. So that's what the equation is saying. But we're going to do a practice just to see how it is used. So let's say that we had basically the same setup that we had last time. I'm just going to put some numbers to it. We have a 6 kilogram object, a 3 kilogram object, and they're separated by 5 meters. We want to know where is the center of mass of this system, and I'm going to say it's defined as from the 6 kilogram ball. This is going to play a part in a second. So the way that we kind of go about figuring out where the center of mass is we first start off with just picking a point. We have to pick a point to be our what we call the reference point. Now they explicitly said that they wanted it from ball B, from the 6 kilogram object. So I'm gonna actually put the point there, but typically I just want to actually move it to the very bottom leftmost point. So in this case, that's this point. Notice I'm not going to put it here because what matters isn't the mass itself, but the center of the mass. We kind of mentioned that in the gravitational unit that it's the center of the object that carries all the mass. So for this object, the center of the mass is going to be the point I'm going to put it at. And then step two is I'm going to figure out what the distance is of each mass from that center point. All right. So, for example, I said that for step one, this is going to be the point that I'm picking. This is my reference point. For step two, the 6 kilogram object is, its center of mass is actually right at the point that I'm picking. So I'm going to say that it is a distance of 0 meters from my point. For this object over here, this is the 3 kilogram mass. Um, this distance we already said was 5 meters. So that is going to be 5. Right? Easy enough. Step three, is we're basically going to look at that top section of some multiply the mass and positions and then add them up. All right. Uh, so in that top part, we have 6 times 0 and then plus 3 times 5. So that ends up being 0 plus 15 or just 15. Step 4 is basically divide by the total mass. Now, for the most part, you're probably going to combine these two steps. I just want to, you know, break it up into the parts so that you knew what I was referring to. So for step 4, we're going to divide it by the total mass. So this is that sum of the MI. That's what that's actually referring to, is what is the total mass in the system. So what we're going to do is we'll say it's 15 divided by 6 plus 3, which is 9. So if I clean this up, basically what this means that it's going to be 1.67 meters from the 6 kilogram mass, which is pretty much what we expect. Again, the direct middle, since this is separated by 5 meters, this would be 2.5 meters. So this would be what where 1.67 would kind of be. All right. Now, are they all this easily? Not really, because that was just two objects. I can easily add three, four, five different objects. Instead of giving you numbers, I could give you variable terms, yada yada yada. So I'm actually going to show you probably the hardest version of this question that I can think of. We're actually not going to be going through that many questions. I do want to point out that this is not really the um, most common question. Probably of the 35 questions, there might be one question where you had to identify the center mass. And some of them might just be as simple as the AP1 questions that we do, or some of them might be what you are going to see here. So just throwing that out there. So this is the hardest one. If this will end up making sense, then the other questions shouldn't be that bad. All right. So here's the question. A piece of wire of uniform cross section is bent in the shape shown below. We want to know the coordinates of its center of mass, x comma y. All right. So this seems really complex, but it actually isn't if you kind of break it up into the base parts. First thing that I wanted to point out is I'm going to start off finding the XY points for a lot of these, but we're going to actually have to do the equation twice. Once to find the X position in the center mass, and once to find the Y position center mass. All right. So first step is pick a point. Again, I'm going to pick the most bottom left-hand corner. That way, because that's kind of like the origin, just makes our life a lot easier. The second step is to find the distance of each mass. Now, I have a uniform wire that is basically one complete object. What I'm going to do is, because they don't give me an actual mass to use, I'm going to say that this mass is M. So I'm going to actually say that this segment is M, this segment is M, this is M, and that this segment, since it's half the length of all the other ones, is half M. Now, if you wanted to make your life a little bit easier, you could have made this 2M, 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 and M. Doesn't matter. So the center of mass for this, I'm going to look at this segment here. I can treat this as basically a wire of uniform mass, and its center of mass would be right in the middle. So its center of mass would actually be at the 1. So what I would say is this segment, which has a mass of 1, not 1, but M, is going to be have a XY center of mass of 0, comma 1. That's kind of what that point is. You should notice why I made this my origin point, because you're going to notice that it's going to make it a lot easier to talk about the coordinates of each of these center masses. All right, so for this bottom segment, the center mass, once again, is going to be in the middle of this entire segment. It's going to be right there. Just like before, I'm going to define it to say that it has a mass of M. I don't really know what its mass is, but I know that since this is one complete object, their proportions should be the same. So this is going to be mass M, and its center of mass will be 1, comma 0, because it's over 1 in the X, but nothing in the Y direction. My third segment is right here. Center mass is going to be over here. Again, same proportion as the other two, so it's going to be mass M, and its coordinates are going to be 2, comma 1. 2, comma 1. This one's going to be the what kind of makes it a little bit dirtier because it's half the length of all the other segments. I have to actually say that its mass is 1/2 m, and its position is going to be right here in the middle. So vertically, that's nice. It's 2, but horizontally, that's going to have a coordinate of somewhere between 1 and 2, which is 1.5. So it's going to be 1.5 comma 2. All right. So now what I'm going to do, I'm actually going to break up step 3 into 2 parts. So the first part's going to be just multiply the m times all these parts. So when I multiply everything, I'm going to get 0 comma m for this first one, m comma 0 for this one, 2m comma m for this one. Being careful that this is half m, not a full m. It's going to be 3/4 m times m for this last point. So putting this all together, I'm going to do the second part of step 3, and I'm also going to combine it with step 4, where I'm going to add all these mx terms and then divide by the total mass. I just need to make sure that I'm doing this separately for x and y. So I'm going to start with the x center of mass. I take all those first x terms and I do 0 plus m plus 2m plus 3/4 m divided by the total mass, which is 3.5 m. So getting this all together, I get 15 divided by 14. For the y coordinate, I'm doing the same thing. I'm taking all those y values and I'm going to add them together. M plus 0 plus m gets me 3m over 3.5m, which simplifies to about 6 over 7. The reason I'm putting them in fraction form is simply just because of the fact that a lot of the practice questions, because originally they didn't allow calculators, um, you had to do this by hand, and it was a lot easier to just do it in fraction terms. So putting this all together, we end up getting that the coordinate for the center of mass is going to be 15 over 14, comma 6 over 7, which can simplify to this, a little bit over 1 and a little bit under 1. So my center of mass will actually be right about here. This makes sense because if this segment was actually completed, it would have been directly in the middle. So getting rid of this top section is going to make it so that the center of mass moves a little bit to the right, since now there's a little bit more right on the right hand side, and a little bit down since this is the heavier side. So makes about enough sense. So this is actually the only practice question we have. So pause the video, work yourself, and we'll go over in a second. All right, so I'm going to end up doing the same thing I did last time. I don't need to do the x coordinate center of mass, but I'm going to do it anyway, just so that we get practice. So again, the center of masses for all these objects, I'm going to treat them as individual objects. So this rod is going to have a mass right in the middle. This is going to be at 0 comma half L. The center of mass here is going to be located at where E is, surprisingly. This is going to be at half L comma 0. And then this one's going to have a point right there. And this is going to be at L comma half L. So putting this all together, we end up getting that mass is 0 times half Lm times Lm, all divided by 3. There's 3 segments, each of equal length, so 3m. This simplifies to be half ml plus ml over 3m, which is going to be 3 halves L over L, because the m's will always cancel out. So I end up getting half L. Again, I didn't need to figure this out because it's kind of, all of them were at half L anyway. So we can move on to the next part. So this is where I'm going to do the y values. This is actually the only one that matters. So again, the coordinates are half, 0, and half. So same thing, I'm just go through each one. I multiply the mass and length. So m times half L, 0 plus mass times half L, divided by 3m. So I end up getting L in the top divided by 3 because the mass cancels out. So my y coordinate system is going to be 1/3 of L. A is at half of L. C is at 1/4. One third is somewhere in between that, which is going to be point B. All right? Easy enough. That's pretty much all you need to do for center of mass. Honestly, it really doesn't get much more difficult than that. Um, you might end up having to combine this with the inertia equation, uh, but it doesn't really change the problem too much. It's basically the same thing that you do, but I'm going to go over how to do that as well. So that's another thing I'll have to do, which really won't make much sense until you get to the rotation unit. All right, if you have any questions, feel free to let me know. Otherwise, good luck and have a great day.